So, starting strong, we'll have Dr. Radia Perlman, also known as the mother of the internet, to present the first keynote of ISBA 2022. Dr. Perlman is currently a fellow at Dell EMC and is taught as adjunct faculty at MIT, Harvard, and University of Washington. She wrote the textbook Interconnections and co-wrote the textbook Network Security. In addition, she holds over 170 issued patents and has received numerous awards, including an induction into the Inventor Hall of Fame, Lifetime Achievement Awards from ACM, SIGCOMS, and Usenix, election to the National Academy of Engineering, induction into the Internet Hall of Fame, and an honorary doctorate from KTH Royal Institute of Technology in Stockholm.
Dr. Perlman's work has made profound impact on how computer networks work today. It enables huge networks like the internet to be robust, scalable, and largely self-managing. Her inventions also transformed Ethernet from a technology supporting a few hundred nodes within a building into one that could support networks of hundreds of thousands of nodes. She's also made important contributions in network security, including key management for data at rest encryption, DDoS defense, and user authentication. Dr. Perlman holds a BS in mathematics, MS, and PhD in computer science from MIT. Let's welcome Dr. Perlman.
So I thought that some of the things I was going to say were heretical, but they've already been said. So so you're not going to be outraged, I hope. So I'm going to talk about, So the advice I always give people when they're starting to do something is start with what problem are you solving? Don't say, well, I know I'm going to use blockchain. And so look at the problem, understand the problem, look at various ways of solving it, and choose the best way. So this is something everyone knows, and when I say everyone knows, it's in quote because it's not necessarily true. So everyone knows that centralized means bad, distributed means good, distributed means blockchain, and so what exactly does distributed mean? What exactly does blockchain mean? So what exactly is blockchain? And this would have been funnier, So one common way of thinking about it is that it's a magic technology that makes anything secure somehow. So just, like if you want a balanced breakfast, add blockchain to it and you'll be even healthier. There are so many variants that it's hard to exactly state what the properties of blockchain are because they're extremely different with the, public versus permission versus whatever. So the blockchain buzzword started as the technology behind Bitcoin. People made money on Bitcoin, and the more hyped it was, the more money rolled in. So there was a big incentive to do a lot of hype. And startups leverage the hype to claim their product has something to do with blockchain. And again, the money pours in. So they were also incentivized to do a lot of hype. And if you hear so much hype, eventually you assume, well, it must be like incredibly important. So, I think pianos are wonderful, but I wouldn't use them for mass transportation. Everything has its purpose. So the goal of Bitcoin's blockchain was don't trust any of these organizations, like countries or banks or whatever. And you want to prevent governments from doing things like shutting your system down or making you pay taxes or following a money trail or preventing you from paying money to terrorist organizations or collecting ransom money. So whether or not those are good goals, it actually led to an interesting design. But there's a lot of misinformation about its characteristics. So what exactly does it do that couldn't have done before? So, yeah. So blockchain is simply a log of transactions where, because of the magic of cryptography, if you include the hash of the previous block, and its hashes have this magic property that you can't create something else that has the same hash, it means that it's infeasible to rewrite history, to take some block in the middle and replace it with a different block, because you'd have to find one that had the same hash because that hash is in the next block. So a ledger is kind of a scary word, but it's just a log of transactions. And it's certainly not a new idea. Almost all systems have a log of who did what, when, and they keep it. So what's different about Bitcoin's ledger? The Bitcoin one, again, I'm specifically talking about that one, it's maintained by thousands of anonymous entities. Nobody knows who these entities are or how many there are, which makes it technically very interesting and challenging to come up with a design that does that. So their design, the blockchain, Bitcoin's blockchain design is breathtakingly expensive, as in this kind of reasonably low volume thing. The energy estimates for just keeping it running is about twice the biggest nuclear power plant in the US. So, and that is intrinsic to the design. If somebody had more compute power than the collective blockchain, Bitcoin blockchain community, they could rewrite history so it's not immutable. It can be, you can rewrite parts of the chain. So there are very simple rules for what makes a transaction valid. The kinds of transactions on Bitcoin's blockchain are this public key pays that public key a certain amount. And in order for it to be valid, it has to be validly signed by the A's public key. Somewhere in the ledger, A had to have received that money so that they're allowed to spend it. And nowhere in the ledger since can they have already spent the money. So with these very simple rules, if someone tried to put an invalid transaction, nobody would, everyone else would ignore that block. So you're prevented from putting false things on there because it's sort of impossible to create a false transaction that anyone else would accept. But there's nothing to prevent miners from ignoring transactions and refusing to put them on the blockchain or reordering them. So is centralized bad? Centralized means one organization is in charge, but it usually does mean that there are multiple servers, so in case one of them goes down, the service is still available. So centralized doesn't mean single point of failure. And usually it means that the data is stored in lots of places, so your data is not going to get lost. And especially if your data is stored in a public cloud, that's their job, is to make sure that the data is replicated so it doesn't get lost. Centralized is the most efficient. And it's also clear who to blame. So if, if the bank or whatever is doing bad things, you know who's responsible for it. And most applications require what I call adult supervision, which is that somebody to go to for help. So if you buy something from Amazon and the merchant doesn't ship it, you go to Amazon and I don't know what they do. They yell at them or they give you your money back or something, but there's someone to complain to. Now, if you're using Bitcoin, I'm not sure what you would buy with Bitcoin, probably something like a hitman. And if he doesn't kill who you paid him to kill, who do you complain to? How do you get your money back? Most of the time, centralized is exactly what you want. So also, like when you withdraw $20 from an ATM machine, your own bank decides, do they have enough money in their account? Okay, I'll do $20, rather than consulting with a consortium of other banks. So centralized doesn't mean bad. In an awful lot of cases, it is exactly what you want. So a centralized approach allows a company to do business its own way, keep its business stuff private. It can keep, it doesn't have to tell everybody who its customers are and what money they're withdrawing. There can be competitors that are also acting independently. So it would be bad if there was only a single bank in your country, but there's lots of them. And so if one of them starts being too obnoxious, then you can go to a competitor. And there's also laws that they have to follow. So if they're doing bad things, you report them to the government, and the government does, who knows what. So the privacy of their customers, and it will be efficient. So what if the bank or the central entity is corrupt? Well, it happens. There certainly have been very corrupt banks. But one thing is, if you have multiple entities that are in competition with each other, then customers can choose to go to a different one. And of course, there's laws and lawyers. So what might blockchain usefully provide? So this might be a property that I'm going to talk about how to do, which is that a company might keep its own ledger. It's private, no one else sees it, but you want to be able to prove to an auditor later that you didn't rewrite it, or maybe even prove that you don't have two sets of books. So how can we do that super efficiently? So I'm going to talk about an incredibly simple design. The problem we're solving is that a company wants to do business all of its own, all under its own control, except there might be an auditor that will check to see if it has tried to rewrite its ledger. And also the bank or the entity itself might want to make sure that some employee there hasn't fraudulently screwed with the ledger to change things after the fact. So I'm going to talk about the concept of having independent entities seal the company's ledger at various points. And once it's been sealed by an independent entity, everything up to then cannot be modified in this design. And I'll explain what it means to seal it. So the solution is each company does business independently and keeps its own ledger. And the ledger can be kept secret from anyone except when you're legally required to show it. And it's sealed periodically by, hopefully, I believe one of the ways to make things robust, even if some things are untrustworthy, is to use lots of independent things. So as long as some of them are honest, then this will work. So you get it sealed by several independent entities that I call notaries. So what do I mean by sealing the ledger? You have an independent entity certify the current state of the ledger. So by signing and time-stamping the hash and returning it to the company to store or keeping it themselves. So this is what a blockchain looks like. Each block has, you hash it, and the hash is included in the next block. And so if you have an independent entity knows what the hash is at some point, and it digitally signs that, or it stores it someplace independently, then this entity can't change anything about that. So the properties of this scheme, there's basically no overhead. The company just does stuff the way that it would ordinarily do it, and in the background, it can say, oh, okay, we've had like 10 blocks now, it's time to get some entities to seal it. It doesn't, that happens asynchronously with any business that you're doing, so you can go off and get these notaries to digitally sign the hash, or to just give them the hash and say, store this. And there's no latency. It doesn't interfere with anything that you were doing. It's extremely efficient. It doesn't really cost anything. And so it can be done in the background. So, and it's also so low overhead that you can use hundreds of notaries. And the reason is you want to use a lot of them is that you don't know which ones the auditor is going to trust. So you want to make sure that it's been sealed by some notaries that the auditor will trust. So, yeah. Okay, so what about dishonesty? So a company could bribe a notary to say, oh, will you pretend that the hash way back then was this value instead? But if you're using enough different notaries, hopefully they're not all bribable. And that's why you should use lots of independent notaries. And the lots of independent notaries could be done just by having a bunch of totally independent notaries that operate themselves, or you could actually create a consortium of notaries that create their own blockchain, and you could put it on there. And then having it on that blockchain sort of is the same as having all of them certify it. And if a notary was discovered to be dishonest, they would completely go out of business. And the company can fail to record certain transactions, like it pays a bribe or something, and it just doesn't put that on the log. So blockchain won't solve that, but nothing else will solve it either. So in summary, if you focus on the problem, you can come up with a very simple, efficient solution. And that solution may not be right for all problems, but it might be the right one for that particular problem. So other problems might benefit from different solutions. The transactions per second with this scheme, you can actually claim that it has infinite transactions per second, because you can have, tens of thousands of entities that are all doing this with their own private business. And so as many entities as you have more transactions per second because they're all doing their own business. And there might be cases where a public blockchain or a consortium might be a better solution. But again, I'm talking about an example where one problem can be solved with a very efficient, simple solution. So yeah, for those sorts of problems, this is extremely simple. So parting thoughts, don't start out saying blockchain is going to be the right solution. Instead, compare various approaches and choose the best one. So I say that a lot in talks, start with what problem you're solving. And one time an engineer came up to me and said, oh, but my manager really wants us to use blockchain. So I say, fine, do what I said, understand the problem, look at various solutions, compare them, and choose the best one, and then tell your manager you're using blockchain. He'll never know the difference. Then just to sort of end on a, I don't know, end on a joke or whatever. So in my book, which is on layers 2 and 3 of networking, I have these little boxes that I call real-world examples to illustrate the point that I'm trying to make. So an example of these boxes is for scalability. I talk about the wine glass clicking protocol, which works great if you have like 4 people at the table. But when you have 12 and everyone has to click with everyone else, it really gets kind of unwieldy. Well, the one that is everybody's favorite in that book, and it's 100% true, it's intended to illustrate that you should know what problem you're solving before you try to solve it. And it's a real problem in this industry. Someone sort of vaguely knows what they're supposed to do. They start writing code. It doesn't work in all cases. They have to write all this other stuff. They come up with this monstrosity. And so anyhow, the real-world example to prove, to make you understand that you should know what problem you're solving before you try to solve it, is that when my son was 3, he ran up to me crying, holding up his hand, saying, my hand, my hand. So I took it and I kissed it a few times. What's the matter, honey? Did you hurt it? And he said, no, I got pee on it. So that's it. Thank you.